Friends, if you recall, in my introductory lecture 1, I discussed the general aspects of reagents and reagent combinations to make you understand that what reagents are chemically, how they are classified, and how medicinally important they are. Now, subsequently, I have also discussed 3 important drugs such as podophyllum, cannabis, and jalap with their pharmacognostic and therapeutic profiles. Now, in continuation to the above, in today's lecture, I will discuss 4 more reagent containing drugs, namely colophony, turmeric, ginger, and capsicum. And to begin with, I will proceed with colophony. Colophony is also known as rosin. Coming to its botanical source, colophony is a solid resin obtained from oleoresin of pine trees such as Pinus palustris and many other species of Pinus belonging to family Pinaceae. Coming to geographical distribution of this drug, Pinus trees grow in colder region at high altitudes, where in south and eastern USA, Pinus palustris is grown. In India and Pakistan, Pinus echinata, Pinus caribea, and Pinus longifolia are grown. In India, pine trees are grown in Jammu and Kashmir, Uttaranchal, and Ooty regions of Tamil Nadu. Now, coming to the collection of the crude oleoresin from pine trees. For collection of the oleoresin from the pine trees, 2 methods are commonly used. The first method is a box method, and the second method is a cup and gutter method. It is important to note cup and gutter method, which is more prevalent in present time. Now, in this method, the metal or the earthenware cups are attached to the trunk of the tree in which oleoresin flowing from the wounded trunk is collected, and the oleoresin so collected in bulk is sent to factories for processing to get the colophony resin. Now, there are certain important notes to mention here on the collection procedure of the oleoresin from the pine tree. Note 1. Box method of oleoresin collection is now less used as the trees from which oleoresin is collected by box method die in only 4 to 5 years after the first collection. Note 2. The use of the cup and gutter method of extraction of oleoresin in these days is common, as the oleoresin can be continuously harvested from trees for nearly 40 years. Thus, more quantity of oleoresin is collected by this method, that is by cup and gutter method, and therefore it is a preferred method. Note 3. A flow of oleoresin can be increased by application of solution of plant hormones or by using culture of the fusarium species or by application of 50% sulfuric acid to the wounded or cut surfaces of the trunk. These techniques collapse and dissolve the cells along the ducts and thus enlarge the channels, which enhances the flow of oleoresin, and thus more oleoresin can be harvested from the pine trees. Now, coming to the preparation of the colophony resin. Oleoresin obtained from pine is warmed in big copper stills with water. The woody matter and chips etc. which float on the surface are removed, after which the still head is then fixed to carry out distillation of turpentine oil from oleoresin. Turpentine oil is collected in separate containers, and finally the molten reagent left in copper containers is transferred to barrels or molds where it is cooled and subsequently packed in suitable containers and sent to the market. Coming to the characteristics of pharmaceutical grade colophony, pharmaceutical grade colophony is pale yellow, brittle mass which fuses at 100 degrees centigrade. However, when heated to higher temperature, it burns with a smoky flame and leaves about 0.1% of ash. Coming to the solubility of colophony reagent is insoluble in water. However, it is soluble in alcohol, ether, benzene, carbon disulfide, acetic acid, fixed oil and essential oils, and solutions of potassium and sodium hydroxides. Colophony pieces are shiny, sharp, and angular glossy fragments. They are translucent, hard, and brittle, and their fracture is shallow. Now, coming to the odor and taste of colophony is faintly terephthalate, meaning thereby that its odor and taste are like that of turpentine. Now, coming to the important notes, it is important to mention here that 1. The composition of the colophony varies with source, preparation, method, age, and method of storage. And second one, before distillation, the pine oleoreagent contains mainly fumaric acid, which during the distillation process is converted to abietic acid. Now, I will be discussing about the constituent profile of the colophony. Colophony contains about 80 to 90% reagent acids, which are anhydride of abietic acid, sapinic acid, and fumaric acid. Colophony also contains rosin, which is a mixture of the hydrocarbons. Now, coming to the chemical test for the colophony, when colophony reagent powder is treated with acetic anhydride and sulfuric acid, a purple color is developed. This purple color finally changes to a violet color. Now, here it is important to note that while performing this test, the following precautions must be observed. Precaution number 1, sulfuric acid should be in concentrate form. And second one, no water droplets should be present in the test reagent or in test tubes. And the third one, the solution be maintained cool. Now, coming to the standards for colophony. Colophony should have acid value between 150 to 180. Now, I am coming to the uses of the colophony. Colophony is used in pharmacy for the preparation of the zinc oxide and other plasters and ointments. It is also used as diuretic in veterinary medicines. The other technical uses of colophony include its use in the manufacture of soap, wax, varnishes, and printing inks. Friends, subsequently to this, I am coming to the another important drug of this particular category, and the drug is turmeric. Turmeric is also known as Indian saffron or curcuma. In Hindi, commonly it is called as haldi. Now, coming to the official source, the turmeric consists of dried as well as fresh rhizomes of Curcuma longa. It is also known as Curcuma domestica. It belongs to the family Gingiveraceae. Coming to the geographical source, turmeric is cultivated in India and Pakistan, China, Sri Lanka, Indonesia, Jamaica, and Peru. In India, turmeric is cultivated on large scale in Tamil Nadu, Andhra Pradesh, and Kerala. Here it is important to note that with 90% world production, India is the biggest producer and exporter of turmeric in the world. Now, coming to the organoleptic characteristics of turmeric. Turmeric is available in two varieties. One, the round variety, which is oblong in shape, and the second one is long variety, which is cylindrical and short branched. Externally, the turmeric is yellowish brown, whereas internally the color of the turmeric is dark orange. The fracture of the turmeric is hard and the fractured surface is horny. Now, I will be discussing to you the chemical profile of the turmeric. Turmeric is an oleoresin drug, meaning thereby that it contains volatile oil and resin both. Now I will be discussing the volatile oil first. The volatile oil fraction of the turmeric comprises of curcumin, gingiberine, turmeron, pinene, phylendrine, camphor, and camphene. The reagent fraction of the turmeric comprises of curcuminoids, which yield curcumin ranging from 3 to 10%, which is an yellow coloring matter and the most important ingredient of the drug. Now, coming to the quality standards for turmeric. Friends, these standards for turmeric are important due to adulteration problems. Turmeric should yield foreign organic matter to the tune of 2%, ash to the tune of 9%, and alcohol soluble extract to the tune of 8%. Now, coming to the substitute of the turmeric, the substitute for the turmeric is curcuma amada, which is used in place of turmeric. Adulterants of turmeric include yellow red soil, starch mixed with yellow dye, and brick powder. These are the common adulterants of the turmeric powder. Now, coming to the chemical test of the turmeric pieces or turmeric powder, when treated with sulfuric acid, it gives crimson red color. Second test, aqueous turmeric solution, when treated with boric acid, it gives a reddish brown color, which on addition of alkali produces greenish blue color. The third test, aqueous turmeric solution, when treated with acetic anhydride and concentrated sulfuric acid, it gives violet color, which when observed under the UV light produces a red fluorescence. Now, let us come to the applications of the turmeric. Friends, turmeric is one of the most widely used commodities among the herbal drugs. It is used as drug and medicine. It is also widely used as cosmetics. The other uses of the turmeric include its use as food additives, as a spice and condiments, and its use for dyeing wool and silk. Now, I will be discussing the uses of curcuma. As medicine, turmeric has anti-arthritic, anti-rheumatic, anti-inflammatory, antiseptic activities. Turmeric has antimicrobial, anti-allergic, anti-cancer, anti-tumor, and antiviral properties also. Curcuma is used as poultice for wounds. Curcuma has very good antioxidant activity. Friends, curcuma has fairness and medicinal anti-wrinkle properties. It is used as coloring agent for creams and lotions. It is also used as blood purifier and wound healing agent. Radioprotective property of the turmeric is due to its free radical neutralizing activity. Turmeric has stomachic and diuretic action also. As hepatoprotective, turmeric is used in the treatment of jaundice and hepatitis. Turmeric stimulates the biliary secretion and it is used to treat gallstones. In ladies, it is used to overcome menstrual pains. Now here, there is one important note that due to its hepatoprotective and free radical neutralizing property, huge quantities of curcuma resin and isolated curcumin are being exported where these are used as preventive medicine or preventive agents against the hepatotoxic effect of alcoholic drinks. And friends, as Indian curcuma is of superior quality, India is the biggest exporter of curcuma and its products to the world. Ginger. Ginger is also called as gingiber. In Hindi, it is called adrak or adrakh, and in dried form, It is called as sunt or sunti. Now coming to the official source, ginger comprises of scrapped or unscrapped rhizomes of Gingiva officinale. It belongs to the family Gingiveraceae. Now let me discuss the geographical distribution of ginger. Ginger is native to Southeast Asia. Ginger is cultivated in India, West Indies, Africa, Australia, Mauritius, Jamaica, China, and Taiwan. Here it is important to mention that more than 30% world supply of ginger comes from India. Now I will be discussing the morphology or organoleptic aspects of ginger. Ginger is a rhizome which is laterally compressed and sympodially branched. External surface of ginger. Externally, ginger rhizomes are rough and buff colored. Here it is important that yellowish white ginger is also available in the market, which is due to the treatment of calcium carbonate solution. Now coming to the odor. Odor of the ginger is agreeable and aromatic, and its taste is also agreeable, but the taste is pungent. Coming to the size of the drug, the ginger rhizomes ranges from 5 to 15 centimeter in length, 1.5 to 6 centimeter in width, and 1 to 2 centimeter thick. The fracture of the ginger rhizome is short, but it is fibrous and starchy. Now coming to the chemical profile of the ginger, ginger is an oleoresin drug, meaning thereby that it comprises mainly of two substances or two things, that is volatile oils and resins. In ginger, the volatile oil percentage is 1.4% and resin percentage varies from 5 to 8%. The starch percentage varies from 40 to 60. The fat content is about 10% and the protein is also nearly 10%. The constant profile of the volatile oil of ginger. The ginger oil comprises of monoterpenes and sesquiterpene hydrocarbons such as gingiberine, camphene, beta-phenydrine, beta-bisaboloin, alpha-farnesene, beta-sesquiphenydrine, and gingiberol, which is a sesquiterpene alcohol. The other components present in minor quantities in ginger oil are curcumin, borneol, citral, and cineol. Now coming to the constant profile of the ginger resin. Ginger resin comprises of gingerol, shogol, gingerone, gingidiols, and hexahydrocurcumin. It also contains gingerone, gingerol, and sogol. There is an important note to mention here. Aroma or smell of ginger is due to volatile oil present in the drug. And the second one, the pungency and pharmacological action of the ginger is mainly due to its resin content. Now coming to the extraction of the ginger oleoresin. Ginger oleoresin is obtained by percolating the powdered rhizomes of ginger with acetone. After percolation is over, the solvent is recovered by distillation under reduced pressure, leaving oleoresin in the flask. The oleoresin is collected and packed in suitable containers for market. Now coming to the organoleptic characteristics of the ginger oleoresin. Ginger oleoresin is dark brown, aromatic, pungent, and viscous liquid. Now I will be discussing the uses of ginger. Friends, ginger is important ingredient of many Ayurvedic formulations such as Chyawanprash, which is one of the best health tonic, providing a variety of health benefits. And another important formulation is Tirakatu, which is a mixture of powders of black pepper, long pepper, and ginger. And it is a good bioenhancer and a good anti-allergic formulation. Now, coming to the other therapeutic uses of the ginger. Ginger is stomachic digestant. It is a aromatic carminative. Ginger enhances the bile secretion and thus it is effective in malfunctioning of liver. Ginger is a stimulant and a good flavoring agent. Ginger is useful in motion sickness as it enhances the gastric motility. Ginger has good antibacterial and antifungal activity. It is effective in cold and cough and in pulmonary and bronchial problems. The ginger oil is used in mouthwash and gargle formulations. Ginger is used widely as anti-emetic agent to check excessive and uncontrolled vomiting during early pregnancy and also during cancer therapy. Ginger is also a good anti-ulcer agent. Here it is worth mentioning that ginger has anti-inflammatory activity which is due to retardation of the prostaglandin synthesis. Now I will be discussing about the varieties of the ginger which are available in the market. Friends, 4 varieties of ginger are available in the market and these are Nigerian ginger, Cochin ginger, Chinese ginger and African ginger. Now coming to the allied drugs of the ginger, allied drugs of ginger are Japanese ginger, Alpinia and Alpinia galanga. Subsequently, I will be discussing the adulterants of the ginger. The exhausted ginger whose volatile has been partially extracted is a good adulterant of ginger. Another adulterant of the ginger is capsicum powder. Now friends, I will be now discussing another drug belonging to the resin category and that drug is capsicum. Capsicum is also known as chilies or red chilies or red peppers. In Hindi, it is known as mirch or lal mirch. Official source of the capsicum is that capsicum consists of dried ripe fruits of Capsicum minimum and Capsicum frutescens, belongs to family Solanaceae. Coming to the historical background, capsicum is indigenous to America, from where it was brought to West Indies during the period of Columbus, and it was introduced in India by Portuguese. Now coming to the geographical distribution, more pungent, smaller varieties come from Syria, Zanzibar, Mombasa and Japan, and these are called as chilies, whereas less pungent, bigger varieties come from Bombay. Normally they are called as capsicum. In India, although capsicum or chilies is grown throughout the country, however, it is grown on a very large scale in Andhra Pradesh. There are varieties of capsicum and I would like to discuss about these. There are 5 main varieties of capsicum available in the market and they are African chilies, second one is Syrian chilies, Zanzibar and Mombasa chilies. Now these varieties of capsicum are smaller in size but they are more pungent. Another variety is Bombay capsicum. This variety is less pungent than the American chilies. And another variety is natal capsicum. This variety is still less pungent. Now coming to the taste of the chilies, capsicum, depending upon variety, taste of the capsicum varies from pungent to intensely pungent. Coming to the color, the capsicum fruits color is red to pale yellow. Now coming to the note, here it is important that size, shape, color and pungency of the capsicum varies greatly with variety, collection time, soil and environmental conditions. Now I will be discussing a little about the constituent profile of the capsicum. Capsicum contains resin, which is called capsicum resin. Capsicum resin is extracted from the capsicum powder is extracted with alcohol. The alcohol extract is thus obtained and from this the solvent is recovered. Thus capsicum resin is obtained. It is dried and packed in suitable containers. Coming to the chemical profile of the capsicum resin, Capsicum resin contains capsaicin to the tune of 1.5%. Note, here it is important to note that capsaicin is an intensely pungent compound of the capsicum. How the capsaicin can be extracted actually from the capsicum resin? Capsaicin is extracted from the resin using the petroleum ether, and then the petroleum ether extract is treated with alkali solution with which carbon dioxide is passed. Now, due to this treatment, the crystals of the capsaicins are formed. These crystals are allowed to stand overnight, and then the crystals are separated. The separated capsaicin crystals are dried and packed in suitable containers for market. Dihydrocapsaicin and related compounds. The another compound is found in the resin is ascorbic acid, which is found to the tune of 0.1 to 0.5%, and it is also known as commonly known as vitamin C. The another important ingredient found in the capsicum resin is thiamine, that is a vitamin B group. It also contains red carotenoids, which comprises of capsanthin and capsorubin. Here it is important to note that capsicum is also a good source of ascorbic acid, as I told you earlier, that it contains good percentage of ascorbic acid, that is vitamin C. The second one, the pungency of capsicum is, as I told you, mainly due to capsaicin, which attributes to 69% of its pungency. The dihydrocapsaicin is responsible for 22% pungency. Non-dihydrocapsaicin and homocapsaicin and homodihydrocapsaicin, each of these are responsible for nearly 1% of the pungency. Now, coming to the important aspects of the capsicum, that is the uses of capsicum and capsicum resin. Friends, the capsicum and its isolated resins are given to treat or cure atonic dyspepsia and flatulence. Externally, capsicum and its preparations are used as counter-irritant. Capsicum and its products are useful in rheumatism, where they are applied as ointment, plaster, poultice, and medicated wool. Capsicum is used to prepare the capsicum tincture also. Capsicum creams are used to treat pain in osteoarthritis, post-hepatic neuralgia, and painful diabetic neuropathy. Capsicum is used in condiments and chutneys and vegetable and food preparations as appetite enhancing agent. Now friends, with this I will be concluding on the episode 2. So to sum up the today's lecture, friends, as planned today, I have discussed 4 drugs of resin category, that is colophony, turmeric, ginger, and capsicum. My dear friends, where colophony has diuretic property and is used in the preparation of plasters and ointment, the drug turmeric is useful in variety of health conditions such as arthritis, rheumatism, cold and cough, and as an antioxidant. It is also used widely in cosmetics as fairness and anti-wrinkle agent. The ginger is useful in cold and cough and asthma, and also as bioenhancer to many herbal formulations. The last drug, capsicum, is used to treat atonic dyspepsia, and it is also effective in treating the rheumatism. Friends, in the next lecture, I will talk on some other individual drugs of a resin group in detail. Thank you very much.